So let's take a look at graphing lines that are parallel. So what does this look like? I'm going to start with simply y equals 2x plus 3. So when I graph it, I realize that I have my intercept at 0, 3. My slope is 2 over 1. 1, 2, 2 up, 1 right, 2 up, 1 right, etc. So there's my slope. There's my equation, my set of solutions. How do I get a line that is parallel, that has the exact same angle or steepness? If I go to write my second equation, I want you to think about this. What about the first equation determined its steepness, its tilt? Hopefully you're saying it's the slope. The slope is what determines the tilt of it. And you're right, it does. So my second equation, what has to be the same in my second equation in order to have the same exact angle or tilt or slope? And that's what it is, it's the slope. So I'm going to do y equals 2x. Now in order for these to be parallel, I'm allowed to now add any number I want except for the number 3 because that was my first line. So 2x, I could leave it like this, y equals 2x, which automatically puts it at 0. I could do 2x minus 2. I could do y equals 2x plus 4. I could do y equals 2x minus 2. We did minus 2, let's do minus 1. Okay, so as long as the slope is the same, I'll have parallel lines. What if it's not the same? Let's do negative y equals negative 3x. Okay, you can obviously see that's not the same, that's not parallel. So I'm going to delete all. So that's parallel lines. Now the harder one becomes this. What if I want perpendicular lines? Let's go back to the original we did, y equals 2x. Now I'm going to leave it at 0. Okay. So if I want a line to be perpendicular to this line, so this line's going like this, to be perpendicular, it needs to be crossing at a 90-degree angle from this. So let's do some thinking. Y equals, first of all, this line, the red line, is positive. How do I know? Because it's increasing. I have a positive slope of 2. It's increasing. Okay. So if it's going to be perpendicular, it now has to travel the other way. Well, what kind of slope does that have to be? Well, it's got to be negative. So let's try this. Negative 2x. Okay, it's now decreasing, which is good. So I'm getting there. The only issue is this a 90-degree angle that it's forming? And the answer is it's not. Well, if you look at the red graph, we know that because this number is getting larger, my graph is getting a little steep. Because my red graph is steeper, all I did was make this negative. Well, guess what? My blue graph is also steeper. So if I want this angle between them to be 90, do I want my blue line to be steeper or flatter? Well, let's change this and make it steeper. Does that help me get an angle of 90? It doesn't. It makes it, here, I'll switch back. There was my 2, there's my 4, there's my 2, there's my 4. It actually takes me further from 90. So because I don't want this blue graph to be steeper, I want it to be flatter. Now, look, it automatically graphs y equals negative 1x just because that's what it does. But, am I close? I'm getting closer. That's a 1. That's a negative 1. What number can I put here that's related to the 2, but is going to be flatter? Now, think about what a flatter graph is. A flatter graph would be a lower value, like a fraction value. All right, let's put it together. Can you think of a fraction somehow related to the 2, that I can put here. Time's up. Ready? I want the reciprocal of this number. So here's the number 2. I want the reciprocal. The reciprocal of 2 is 1 half. And believe it or not, this will make a 90-degree angle. So when I graph perpendicular lines, I want the opposite reciprocal of that number. Let's change this. Let's make this a 5. What's the opposite reciprocal of 5? Negative 1/5. Those are perpendicular. Let's try this. 2/3 x. What's the negative reciprocal of 2/3? Negative 3/2. And that's a 90-degree angle. What if I start with negative 8/3? Negative 8/3x. What would be the reciprocal of negative 8/3? It would be 3/8. And every time I do the opposite reciprocal of the slope, I will get